Hi guys, today we're going to take a look at pages 12 and 13 of the Unit 6 Classwork packet. So the first thing we're doing is kind of like a little bit of cleanup. There are actually 4 points of concurrency. Thus far we've learned about the Circumcenter, the Incenter, the Centroid, right? There's actually another one called the Orthocenter. Now the Orthocenter is formed by the altitudes in a triangle. What's an altitude? Take a look at the diagram they give you. An altitude, what it looks like is like a line that goes straight down from a vertex to the opposite side, and that means it's perpendicular, right? By using formal language, we'd say it's a segment joining a vertex to the opposite side so that it is perpendicular to that side. Now, look at where it says orthocenter. The 3 altitudes of a triangle, like if I drew all 3 of them, intersect at a point called the orthocenter. So take a look at that diagram. The altitudes are the segments that go from a corner or a vertex to the opposite side, and they're perpendicular. So in that particular diagram, my altitudes would be AE, BF, and CD, and the orthocenter is where they cross. Now notice how this section is super short. The reason for that is, guess what? There's actually no special property of the orthocenter that you're expected to know. So you can rest easy here. There are no problems to solve with it. For those of you who pursue higher things like higher math and geometry in college and stuff like that, there is something called Euler's line, which is a fancy way of saying that the circumcenter, incenter, centroid, and orthocenter are all collinear if you were to actually draw them all out. But I don't want to terrify anybody right now, so just calm down, okay? Now, let's actually take a step back and review everything we've learned. Let's take a look at that centers review at the very bottom, okay? Page 12. The 3 perpendicular bisectors of the sides of a triangle intersect at the circumcenter. By contrast, the 3 angle bisectors, all right, or you could say the angle bisectors of the angles of a triangle intersect at the incenter. The 3 medians of a triangle intersect at the centroid. The 3 altitudes of a triangle intersect at the orthocenter. A circumcenter is equidistant from the vertex. By contrast, number 6, an incenter is equidistant from the sides. Okay? Now, here's what I'm going to tell you guys. All right? Take a look with me at page 13. Page 13 kind of takes all this stuff and puts it together for you. You want to know those diagrams. Let me say this again. You want to know those diagrams and which point of concurrency they correspond to. On your Unit 6 test, you may be asked to match the diagrams with the points of concurrency that they're depicting, okay? So please keep that in mind. So, just going through point by point, the circumcenter is created by the perpendicular bisectors, okay? And the circumcenter is equidistant from each vertex. Now let's move on to the incenter. The incenter is created by the angle bisectors, and the incenter is equidistant from each side of the triangle. Now on to the third one. The centroid is created by the medians. A centroid is created by a segment connected to the midpoint of the opposite side, all right? So in other words, it's a segment coming from the corner to the midpoint of the opposite side. And last but not least, the orthocenter is created by the altitudes, and an orthocenter is created by a vertex connected to the opposite side so that it is perpendicular to that side. All right? Now, what are some test taking tips? Like, how are you actually going to get these diagrams and like remember which one's which? So here's something that I actually look at quite a lot, okay? The easiest one for me is actually the incenter. And the reason is the incenter shows congruent angles in the corners. Notice how like each of those angles in the corners is split in 2 equal parts. So that obviously shows you're dealing with angle bisectors. And that means that you would be dealing with an incenter diagram. So I find that one to be the easiest, right? The next one I find to be pretty easy is the centroid. The reason the centroid's easy is that there's no right angle anywhere. Notice, no right angles. Like, I'm not even joking, right? Because there's no right angles, that means there's no perpendicular bisectors, there's no altitudes, and that only leaves you with the centroid. For the circumcenter, what I look for is I look for the fact that there are perpendicular, for the perpendicular bisectors, and I look for the congruent split sides. So each side is split into two equal parts because taken together, those show me I have perpendicular bisectors.